Welcome to this presentation from the Microsoft Virtual Academy, where we will be covering Part 2 of Windows Server 2008 R2 Failover Clustering Feature Overview. I'm Simon Perryman, a technical evangelist with Microsoft and a former program manager on the clustering team. In Part 1 we discussed the hardware and software considerations and the feature set around them when deploying a 2008 R2 cluster. In this section, we'll be discussing the management, supportability enhancements, as well as some of the improvements to highly available applications and services running on Windows Server 2008 R2 Failover Clustering. Failover Cluster Manager is one of the key pieces of the Failover Clustering product. It allows you to centralize the management of not only the highly available services and applications, but the entire hardware layer, including the storage and the networking. In Windows Server 2008 R2, clustering now supports up to 1,000 virtual machines per cluster. Now these can be spread across 16 nodes. However, there is a limitation from Hyper-V of 384 virtual machines per node. Generally, we do not see customers come anywhere close to this, so you could assume that there's enough capacity to handle as many VMs as you need. PowerShell support was one of the other major management enhancements made in Windows Server 2008 R2. PowerShell is a new scripting language and programmatic interface which is set to replace cluster.exe, which was the previous clustering command line tool. PowerShell is great because it has built-in help, which makes it easy to learn all of the commandlets and familiarize yourself with PowerShell and its modules. Compared to clustering back in 2003, PowerShell has a lot of management improvements as well. It gives you the ability to run validate, create clusters and highly available roles and workloads, manage Hyper-V and your cluster shared volumes, as well as generate dependency reports. This gives you some great flexibility and management options if you're running a server core or Hyper-V Server 2008 R2 cluster, where you don't have the full UI and full GUI of Failover Cluster Manager. Let's take a quick look at how powerful PowerShell can be. Here we have the same cluster which we configured in Part 1 of the presentation. I'm now going to go and launch PowerShell. When I launch PowerShell using this mechanism, it's going to automatically import all of the PowerShell modules for me, including the Failover Clustering module. Now I'm going to run a demo and quickly show you all of the PowerShell commandlets for clustering. As we can see, there's quite a lot, and you have a lot of flexibility in how you can manage your cluster with PowerShell. Not only can you add and remove components to the cluster, but you can get information about how the cluster is operating. You have the ability to move groups around the cluster, as well as change different settings and parameters. You can start and stop the cluster, or different groups, and run validate using the test cluster commandlets. Let's take a look at some of the validation tests. Here you'll be able to see the full suite of tests, which are the same as if you were running Failover Cluster Manager in the UI. You could collect information about the cluster, learn more about it, test the networking, the storage, as well as the system configuration. Here we're going to simulate validating the entire cluster. Now, since this cluster has already been validated, I've simply copied the output into a text document to make it easy to view for you. As you can see, when validating the cluster, it goes through the same steps and the same process as you would using the GUI. And here it gives you not only the status, but which tests are running at which time. At the end, it will go and print out that same report and tell you where this report is stored. Let's actually run one of these tests now. Here we're going to test the validate all signed drivers test. What this is now doing is contacting all 3 of the nodes in my cluster, running this test, ensuring that everything works, and upon completion it's going to go and send me a report. Here we see that the test has been complete, and there have been no failures, so I know that this setting is configured. Now, if I wanted to create a cluster, once again, it would be very simple. Using the commandlet, specify the node name and the cluster name. And you go ahead, and it will go and build your highly available cluster with just one line. Since we've already gone and deployed the cluster, this doesn't make sense to us, so we're just showing this for the sake of the demo. Now, let's get some more information about this cluster which we've already created. We can see here that my cluster is called Cluster MVA. Let's get some information about the nodes. Here we see my 3 nodes, and we see that they are up and running. Now let's look at the cluster networks. Those 3 networks are also up and running. Let's find out how the network interfaces are doing. Once again, everything is looking healthy. Now, clustering gives you the ability to also manage Hyper-V as well as cluster shared volumes, and so I just want to quickly show all of these different commandlets related to cluster shared volumes. You can add and remove disks from CSV, repair them, and just get more information about the state of them. Another powerful feature of this scripting utility is the ability to set and create variables. You can use these variables throughout the PowerShell operation to go and pass different components or different parameters in different areas. So, for example, I'm going to set some variables for my node name and for the name of a file server which I want to create. I'm then going to set a variable for the disk that I want to use, and now using this single line, I'm going to create a highly available file server, passing these 3 variables. As you can see on the left, I currently do not have any services or applications, but you're going to see once this starts executing that we are going to now go and create this new highly available file server. It really is as simple as that, just specifying the disks, specifying the type of highly available service, and giving it a name. Once this file server has been created, it will automatically come online, and then it can continue to be managed either through PowerShell or through the graphical user interface. Now we can see that this is created and it's online. If we want to get a list of all of the resources in a specific group, we can do this as well. So we can see that this highly available file server that I've just created is using cluster disk 1, it's using a DHCP assigned IP address, and we have the network name, MVA file server. Now let's get a few more resources on that specific node. Here again I'm going to use the variable, and I'm going to pipe the get cluster resources through the same commandlet. So I'm now saying that I want to get the cluster resources on this specific node. Here we get our list of resources, and as we go back over here, we can see that we have a similar list of resources. PowerShell also gives you the ability to go and configure remote cluster administration. Using PowerShell, you can set specific access points and access protocols for different users. An example of when this might be useful is if you're in a large enterprise and you have different people responsible for different areas of the cluster. You might have the SQL database admins that are purely responsible for the actual SQL database and the SQL service itself. Yet you still might have your cluster administrators that are responsible for the infrastructure and for keeping that SQL database highly available. In the case that there's a problem and the database crashes, the SQL admins might want to investigate and see whether it is a cluster problem. However, the cluster admins might not want to give full access to the cluster to the SQL admins. In this case, we can give the SQL administrators what we call read-only access. They have the ability to view the cluster, view the groups, view the states, but they can't take any actions upon it, such as bringing a resource online or moving it over. This gives more flexible security options and helps prevent accidental downtime with people manipulating the cluster who may not be as familiar with the cluster's operation. Now we're going to talk about some of the supportability enhancements that came in 2008 R2 clustering. We added numerous performance counters which will help you tweak and manipulate the cluster to ensure that it's up and running. We could go and query the status of resources or groups, and then we can also check things such as API handles, how fast data is being accessed to a cluster disk, the state of the cluster service, the frequency of network updates, and a lot more. This really gives us the ability to understand where any bottlenecks may be throughout our infrastructure, so that we can go and resolve them and maintain higher availability, and not only keep our cluster online, but keep it performing as optimally as possible. Another supportability enhancement came around enhanced logging. Now, clustering now has the ability to go and use these different logging channels. This gives you information about what has happened on the cluster so that you can trace back to when a problematic event may have occurred. There are multiple different logging channels: diagnostics, administrative, operational, and a few others customized, such as cluster shared volumes. Now, by default, the debug logging channels are disabled by default, and the reason for this is that they are very noisy, and you don't want them flooding the logs with perhaps unnecessary chatter for day-to-day operations. So if you need to go and use these debug logging channels, you have to explicitly enable the log, then you can repro the problem, and then disable the log again, just so that you don't have this additional noise and additional chatter which may be interfering with other cluster logging events. The cluster log is also converted to an ETW eventing channel so that you can now view all of this information through Event Viewer. The cluster events are built directly into Failover Cluster Manager, so you can simply click on the graphical user interface, select cluster events, and it will take you to all of the cluster events straight through the same interface without having to open up Event Viewer. This gives you the ability to just quickly understand what's happening across all of your nodes throughout the cluster. You can sort events based on the node, based on the event, or based on the category, giving you a lot of flexibility in how you can interpret and understand what has been happening with your cluster. There is also the ability to save these event files as EVTX files. This means that if you come across a problem, it's very easy to go and send this information to product support so that they can go and review all of your events and see if they can triage the issue that you're experiencing. When we think about supportability and serviceability, planning how we handle service packs is an important consideration. Service pack upgrades are always recommended, and Windows Server 2008 R2 Service Pack 1 was released in early 2011, and it's highly recommended that you go and acquire this service pack for your cluster. There is improved integration with Hyper-V and System Center Virtual Machine Manager. For example, we've improved the performance of how all of our WMI calls happen between the cluster and between SCVMM to give you not only a better SCVMM experience, but to give you overall faster cluster performance. We've also added several additional validation tests, or updated some and made them more resilient to detect all different types of failures. This is just going to give your early deployment and your testing infrastructure more opportunity to detect problems and to make recommendations to give you the most highly available infrastructure possible. When we look at patches and updating service packs, there are several best practices which are important to keep in mind. It is always recommended to move to the latest service pack because these service packs have been well tested with all of the fixes together to give you a much better experience. Windows Server 2008 R2 Service Pack 1 was released in early 2011, and there are numerous clustering enhancements, in addition to several other features which you may find useful if you're using Hyper-V, such as dynamic memory and remote FX. Some of the clustering improvements really focus on giving you an even more highly available solution. These are done through detecting additional points of failure and making recommendations to eliminate them, such as if there are additional down-level network disconnection events, we can now detect these and we can trigger failovers to ensure that your clients can still connect to their highly available services and applications. We've added additional integration components focusing with Hyper-V and System Center Virtual Machine Manager to give you a much better experience. For example, we improve the performance which all of our WMI queries get accessed while using SCVMM. This not only makes SCVMM faster and allows it to scale better when it is accessed in a cluster, but it makes the overall performance of the cluster much faster. We've also added several additional validation tests, which are going to ensure that you're continuing to use the best practices possible while maintaining your highly available infrastructure. When we apply patches, there are some best practices that we recommend. The most important, of course, is to test the patch before putting it in production to ensure that something unexpected does not happen and that you maintain your highly available cluster. When you go and patch a node, it's important to remember to pause the node first. Pausing the node is a feature which essentially locks it so that no other groups can move onto it while it is being serviced. You wouldn't want to be emptying a node for patching and have other virtual machines or highly available services move onto that node which you're trying to triage. So by pausing the node, you can enforce that no other services or applications will move to it. We recommend patching the most passive node first, meaning the node which has the fewest running applications on it. This is because there will be less initial failovers for moving the services and applications off of this first node. And as you go and serially patch every node in your cluster, this is going to reduce the overall number of failovers which you need to make to patch the entire cluster. When you go and look at the Windows Update settings, there are a few recommendations we have to help improve high availability. The first is to disable automatic reboots, because you don't want your node unexpectedly rebooting due to a patch. However, sometimes nodes can still reboot because of group policy or other reasons even while you have this setting enabled. So we recommend staggering the actual time across every node so that in the event that it does unexpectedly reboot due to a patch, not all of the nodes reboot at the same time, but they reboot an hour apart so that they can maintain high availability of all of the services and applications. Another best practice is to automatically download the patches, but don't actually install them. When you install them, that can go and trigger the reboot logic, but by downloading them, you already have the binary files which you need on each node, so that when you do start your patching cycle, you've eliminated one step, and you can make the overall patching cycle much faster, because you're only installing the patches on every node, instead of downloading them and installing them on every node. And finally, don't reboot unless you have to. Not all patches require reboots. Reboots are generally determined by looking at whether any of the binaries which the patch contains are currently in use on the system. So only go ahead and do that reboot if you're actually required to and you see the notification. Otherwise, it's safe to keep your cluster node up and running to maintain higher availability. Finally, we are going to look at the highly available applications and services which run on top of your cluster. In 2008 R2, we added support for two new inbox roles, DFS replication and remote desktop connection broker. However, we still find that over 90% of our clustered workloads use Hyper-V, Exchange, File Server, Print, and SQL. We support most of the inbox server roles and features, included DFSN, DHCP, Distributed Transaction Coordinator, ISMS, Microsoft Messaging Queue, NFS File, and WINS. Now, you may have a service or application, or even a custom line of business workload which you want to cluster, and that is fully supported using Windows Server Failover clustering. The cluster has an extensible model, which we call generic containers, and this essentially allows you to plug in any custom application, script, or service and make it work with the cluster. There's a simple wizard where you go and specify a few parameters, and after that point, we will maintain this services or application's high availability and allow it to fail over between different nodes in the cluster. DFS replication was one of these new features which we added in 2008 R2. This is essentially given the multi-master replication engine, or each node of it, high availability. Now, to be very clear, the entire DFSR solution itself is not a cluster, but each group member, each replication member, can be made highly available. So for example, if you're working primarily in your corporate office, and it's important to have continual replication to branch offices, you might want to make the node at the central office highly available. This way, if this central office node or server crashes, the DFS replication engine can fail over to the other node in the cluster, and you can still have replication out to your branch office. Essentially, each replication group member can form its own cluster. The second major feature, which we added support for in 2008 R2, was the Remote Desktop Connection Broker. Remote Desktop Connection Broker is essentially a mapping between client connections and backend servers, or backend remote desktop connections. If you're running in a server farm and have many clients and many servers, and you want to ensure that the same client always gets connected to the same server, making this database highly available is a best practice because it can always ensure that it's there, so that when clients are coming in, they can always get connected to the same backend database. Print Server had a few high availability improvements in Windows Server 2008 R2. The primary one is allowing isolation of all of the different print processes. If you did print clustering in previous releases, you could find that having a single bad driver could take down the entire print cluster. Now, with this enhancement, we have what's called driver isolation. This gives us the ability to have drivers run in their own process. This way, if a single driver crashes, it will only take down that specific process, and it will not impact the rest of the print server or any other drivers. By default, all of the print drivers will stay in what's called a shared pool. This means that the print spooler runs in one process, and then all of the drivers run in a shared process. If you find a particularly faulty driver, you then want to go and isolate it into its own process. This way, you can have the faulty driver not impact anything else, yet you still have a reasonable performance without having additional overhead of having every single driver run in its own process. Now, we briefly touched on Hyper-V and said that this will be covered in detail in other presentations in the MVA. Now, let's quickly go back to the demo, and we'll see some of these features put together. First of all, we could go and enable cluster shared volumes. We click this setting, and there's an end-user license agreement. This just simply reminds you that CSV is supported only with Hyper-V. So this means that you should not go and put a SQL database or a file server on your CSV disk, as it will not work. Once CSV is enabled, we can now go and add regular cluster disks to CSV disks. It's extremely simple. We simply say we want to add storage. We could go and look at which disk we want to add, and in this case we will go and add 2 of these disks which have a lot of spare capacity. So converting a traditional cluster disk to a CSV capable disk literally takes a few seconds. Once these disks are ready, you'll actually notice under the C cluster storage file that we now have 2 new folders which are created that are going to be used specifically for cluster shared volumes. All nodes will access this CSV volume using the same way. So every node will be able to access C cluster storage volume 1, and it will get pointed to the same disk. Now that we have our CSV disk deployed, we're going to go and create some highly available virtual machines on this. Rather than opening up Hyper-V Manager, we can actually just go and create a new highly available virtual machine straight through Failover Cluster Manager. So a single management interface, and you can see the familiar new virtual machine wizard. It's going to ask me for a name, and it's going to ask me where I want to go and store this VM. Since I want to make this VM a highly available VM on cluster shared volumes, I want to make sure that the C cluster storage path is specified. It's going to ask me for memory, networking connections, and it's going to ask whether I want to use an existing VHD or whether I want to create a new one. In this case, I'll install the operating system later. I'll click Finish, and not only will we now have created a virtual machine, but it will automatically be made highly available and added to the cluster. And now we can see that the virtual machine has been created, and we get a report that we can again view. Now you'll notice that the VM is in an offline state. This is because we often want to do configuration changes to it, or adjust the settings, or install something in the operating system before we go and bring it online. We can see some of the properties that we've just discussed with persistent mode and auto start, as well as enabling the heartbeat settings so that we can detect high availability and we can detect whether that VM's operating system has hung or it's crashed. Here's where we could go and configure the networks for live migration, and if we click here we can actually go and look at the settings of the VM. So there's no need to jump back and forth between Hyper-V Manager and Failover Clustering Manager. Everything can be done using the single management infrastructure. Now let's bring this virtual machine online, and we'll just do a quick live migration. We can currently see that it is hosted on node 606, and so let's go and live migrate it to node 608. Now live migration will vary depending on what's running inside the guest operating system. In our case, I don't have anything running inside the guest, so it really only takes a few seconds. If I had a SQL database with a lot of transactions and there was a lot of in-state memory changing, it's possible that this could take a much longer time. Well, here we see that we have successfully live migrated this VM from VW606 to VW608 with no downtime. Windows Server 2008 R2 has a lot of new features, particularly focused on Hyper-V. You can learn more about the Hyper-V improvements in our other sessions, but you should also realize that we've expanded support for several new roles, and you can pretty much put anything on top of a cluster, whether it's a file server, SQL database, Exchange mailboxes, or even a custom line of business application. There really aren't any special requirements with clustering. It just works. Just simply put your hardware together, connect it to a SAN, connect multiple networks, and run validation, and we will ensure that not only will the cluster function with high availability, but that you're following the best practices to have the highest available solution possible. Here's some additional resources from the cluster team. In particular interest is the cluster blog, which is regularly updated with best practices, tips and tricks, as well as events where the cluster team is speaking, so you can learn more about this interesting technology. This video was a part of the Microsoft Virtual Academy. We hope that you enjoyed it and you want to go ahead and deploy your own highly available infrastructure using Windows Server 2008 R2 failover clustering. Thank you.